Okay, we start our topic on propositional logic. Okay, what do you mean by logic? That is the thinking capacity of ours. That is logic. You just here there is an example. Penguins are black and white. Okay, we know that some old TV shows are black and white. Then can we say that some penguins are old TV shows? It is logic that we analyze penguins are black and white and TV shows are also black and white. So we cannot say penguins are old TV shows. That is our reasoning capacity. Okay, that is logic. Next, what is logic? Logic means it is a truth preserving system of inference. അതായത് truth preserving system of inference. What do you mean by truth preserving? Truth preserving means and if the initial statements are true, then we think that the inferred statements will be true. Okay, and system means it is a set of mechanism based on the syntax. And inference means the process of deriving, inferring new statements from the old statements. Okay, and next we have to discuss about propositional logic. Logic we have already discussed that logic is our capacity to analyze something. Okay, then propositional logic means proposition means it is just a statement that may be true or that may be false. Okay, example means this class is MCA 3. It is true, we know that. And today is Sunday. We know that it is not true because today is Monday. And now it is currently raining in Bombay. Can we? No, maybe there will be rain or not. Okay, that means every proposition is true or false, maybe unknown also. Okay, next propositional logic. Okay, propositional logic means it may be a simple proposition, means that it may be a statement only that we may denote it as capital letters. We denoted all propositional logic using capital letters. That means just A. A means we just in the previous statement we write a statement that it is class MCA 3. We just it denoted as A and A is true. Okay. There will be negation of a propositional statement. Negation means the negative statements. That is, it is not class MCA 3. Means not A. അതായത് we represented as negation A. Okay, we discussed it later. And there may be, we can join or connected two propositional using different connectives. Here just example and or. We will discuss it also later. And also we can join more than one connectives together. Okay, next truth tables. Truth table means we already said that there may be a proposition may be true or false. Okay, we can denote it true as 0 or true as 1 or T or false as 0 or F. Okay, and we can draw tables using these truth values. Okay, next we discuss about each and every propositional logic. First one, logical negation. Okay, negation of a proposition, we already say that it is the not statements, and we represented here the symbol negation A. And statement A is it is snowing, means India. Now it is snowing. And what is the negative? It is not snowing. Okay, that is the symbol negation A. And next example is Newton knew Einstein. And negation, Newton did not know Einstein. We already studied in our smaller class the positive and negative statements. Okay, and the truth table can be represented as A. A means it may be 0. 0 means false. Okay. When the statement false, then negation will be true. That is 1, or we can denote it as T also. Okay. When the statement is true, the negation will be false. Okay. Next, the logical and conjunction. Here, conjunction of A and B is A and B. A and B means just we know that, and that means CS 160 teaches logic 1. Also there is another CS 160 teaches Java. We can combine together as CS 160 teaches logic and Java. Means two statements are combined using and connected. That is represented as A and B. Okay. There is another one. I like fish. I like sushi. I like fish but not sushi. How can we connect? First one A and second one the negation of B. That is connection A and negation B. Okay. Next we will discuss about the truth table for conjunction. Okay. Here when both are true, then only the conjunction will be true. Otherwise, it is false. Okay. Just for an example, mm, I like mango. First statement, and second statement means I like ice cream. That is A and B. Okay. Then I like mango. It is true, and I like ice cream. That's also true. Then I like mango and ice cream. It's true. That is the last case. If both are true, then it will be true. And first, both I did not like mango, I did not like ice cream. That is the false statement. Can it also false because I already like mango. The same way, we can analyze both when first statement is false and second statement is true, then the conjunction will be false. In the same way, first statement true and the second statement false, then the conjunction will be false. Okay. Next one, logical or. Otherwise, it is known as disjunction. Disjunction means or. First one, for an example, we can analyze today is Friday. Second, B in our end, it is snowing. That is, we can use or today is Friday or it is snowing. In this case, we can clearly know that first statement may be true and second statement also may be true. But there is no connection between that is it is not compulsory to happen both are together. So we can say when it is false, otherwise both are false, then only this or statement will be false. Otherwise, it may be true. Okay, that is we represented in truth table. That is when both are false, it will be false. Otherwise, all the case it will be true because there is no compulsory to happen both the statement together because the conjunction is or. Either the first statement may happen or second statement may happen. Clear it? That is in the truth table. When both are false, then the or exclusive or will be false. Both are true, that will not happen. That is false. Either one or the second one may be happen. Clear it? Okay. Next one, conditional and biconditional. implication. That is our conditional statement we already uh, studied in English grammar. Conditional means if then. That is it. But here also, if a statement happens, then the other statement happen. Okay. If first statement is happen, then the second statement should be happen. That is compulsory. But there may be chance to happen the second statement if the first one is not happen. But there is only first condition that in the if the first statement happen, then the second will be happen. Okay, here the truth table, just listen to the truth table. If the first statement is false, what happen? The second statement also happen. Then in that condition, a conditional B is true. Okay, in the second one, if first statement is false, then the second statement is true. Okay, that may happen. Why? If first statement is happen, then the, there is a condition, but there may be chance that second statement may be happen. Okay, so what? A conditional B is true for 0 and 1. In third row, if if the first statement is true, what is the condition? If P then Q. If A then B happen. It should be happen. So there is no situation, such a situation that B is false. So a conditional B is false. Okay, clear it. Next, biconditional statement. In biconditional statement means that if and only if. And then that means when the first condition is true, then only the second condition is true. If the first condition is false, then the second condition should be false. If and only if. There should be an existence of second statement if there exists a first statement. Clear it? So, that in the truth table, if both are false or both are true, then will be the conditional statement is true. Otherwise, it false. Okay, there is an example. First statement A. A programming homework is due. B. It is Tuesday. A conditional B means if a programming homework is due, then it must be Tuesday. This is the same as if it is Tuesday, then a programming homework is due. Is it right? Both statements are right or wrong? Okay, we can clear that the first statement and second statements are not true, not same. Okay. Example for biconditional. A statement means you can take the flight, and B statement means you have a valid ticket. Okay, biconditional B means you can take the flight if and only if you have a valid ticket. This is same as by if you have a valid ticket, if and only if you can take the flight. Okay, both are same. Next, compound truth tables. We already said that in our first slide we can combine more than one connectives together. Okay, that becomes a compound statements. Okay, now we can do some exercise. First example, just to draw the truth table for A or B and negation A. Okay, when we write the truth table, just listen. First you should write A, second B, then we should write each and every statement. Here we want to A or B, then negation A. First you should find out A or B, then negation A, then we combine A or B and negation A. Okay, just write. Okay. Next concept means tautology and contradiction. Tautology means when we construct a compound proposition, if the last columns all the values are true, then it will be a tautology. And contradiction means if the last column completely false, then it will be a contradiction. And another concept, contingency means it may neither tautology nor contradiction. Some values are tauties and some values are false, then it will be contingency. And there is another concept, satisfiable means if there is at least one assignment may be true. Any one value may be true, then it can be satisfiable statements. Okay. Some examples. When we say A or negation A and negation A. Just to consider, and here A or negation A, the all values are true. That is, it is tautology. And in the case of A and negation A, all values are false. It is contradiction. Clear it? Okay, next concept means logical equivalence. Okay, when we say that two compound propositions are logically equivalent, that means if P conditional P biconditional Q is a tautology, P biconditional Q, we can construct this truth table for P and we can construct the truth table for Q. Then we just construct the truth table for P by conditional Q. If it is a tautology, then we can say that P is equivalent to Q. Okay. We can say some rules, and first rule is De Morgan's law. Okay, De Morgan's law means negation of P and Q equivalent to negation P or negation Q. Okay, negation of P and Q equivalent to negation P or negation Q. Okay, another reverse of the first statement, negation of P or Q equivalent to negation P and negation Q. Okay, we can prove this using the truth table. Can you? Okay, here we write. Just we draw the truth table for negation of P and Q. Then we just draw the truth table of negation P or negation Q. The values are equal. The negation of P and Q values and the negation P or negation Q values are in the columns same 1 1 1 0. Okay, then we can say both are equal. Okay, also we can prove using the above equation, that is negation P and Q by conditional negation P or negation Q. Here when we write the truth table, next column also, that is biconditional, we know that 1 biconditional 1 means 1 biconditional 1 means 1 biconditional 1 means 1, 0 biconditional 0 also 1. Okay, that is a tautology. Thus we can prove that negation of P and Q equivalent to negation P or negation Q. Okay, here also negation P or Q. You just draw the table as a homework. Okay. Next, there are some more equivalences there in logical equivalences. Okay, just you show the example. Show P conditional Q equivalent to negation P or Q. It is an illogical equivalence, but you should prove using the truth table technique. Okay. Also, there is another law, distributive law. P or Q and R equivalent to P or Q and P or R. Yeah, here draw it, but you should draw prove using truth table. Just write down. Okay, P and T equal to P, P or F equal to P. That is the name of that law is identity law. And second one, commutative law, P and Q equal to Q and P. The same way, P or Q equal to Q or P. Okay, next absorption law, P or P and Q equal to P. And P and P or Q equal to there is some laws with the conditionals and biconditionals. Okay, P conditional Q equal to negation P or Q. I just previously give a questions to prove that. P conditional Q equal to negation Q or negation Q conditional negation P, and negation of P conditional Q equivalent to P and negation Q. And there is some rules in biconditionals also. You should study thoroughly all the rules because this is useful to do problems in the next section. Okay, also you should know the precedence. Here the negation has the highest precedence, and next and has the highest precedence than or, and or higher than conditional and biconditional. Okay, you should know the precedence, and also you should study all the laws. Okay, you should prove. Okay, next one, logical or, otherwise it is known as disjunction. Disjunction means or. First one, for an example, we can analyze today is Friday. Second B in our end, it is snowing. That is, we can use or today is Friday or it is snowing. In this case, we can clearly know that first statement may be true and second statement also may be